Howdy, this is Mr. Potter. In our last Magpie video, we're going to talk about something called refactoring. The idea that once we have code in our program, it turns out that the first time we wrote the code, it may not have been the most efficient way to write the code, and later on we can come out with the more efficient way to write the code. So, for example, if I were to take a look at my Magpie 5 class here, there's this thing down here called get random response, and what we've been doing is we've been picking a random number, and well, let me go ahead and show you what we've been doing in the past. I'm going to jump back to the activity 4. This is what our Magpie 4 class had looked like so far with our get random response. We had an integer which kept track of the number of responses, which in this case was 4, and we'd have to change this number in order to add responses. And then we had this math.random. We would go through the number of responses, and we'd have a whole bunch of if-else statements. And we'd have to return it based on a 0, based on a 1, based on a 2, based on a 3. And if I wanted to add another response, I'd have to add an if-else here and target again. But I'd have to make a big change here, and I'd have to make a big change here. And this is not the most efficient way to do this. I want to take a look at the way Magpie 5 does it. Magpie 5 takes this method right now that's 20-something lines long, and really breaks it down to just 3 lines here. I've got the header telling me to get a random response. We created a new random number generator object, and we just get another random number. Now, if this doesn't make sense, we haven't really talked about the random class, so let me just go ahead and take this line out, and I can actually make it shorter. Instead of using r.nextInt, what I can do is I can take math.random and multiply it times random responses dot length, and then take that product and cast it as an int. That does essentially the same thing. The thing is, I have this private array of random responses, and this is an array literal. So I've got the open braces, and then this is an array of strings. So I've got a whole bunch of strings separated by commas inside of braces. This is what we called an array literal when we were talking about arrays. So I'm asking the computer what the length of that array is. I'm multiplying it times math.random, which gives me a random double between 0 and 1. and then I'm casting that as an int. So I'm going to get a 0 or a 1 or a 2 or a 3, which, amazingly enough, are the indices of this array. And I can add another element to this array and say, I'm bored. Tell me something different. And now the length has changed, so I don't have to change anything in this method. This is actually a shorter way to write this, but I don't have to change anything in this method. I can go ahead and get my Magpie runner to run. And I can go through all the choices. So you don't say, you don't say, you really think so, you don't say, I'm bored, tell me something different. We eventually hit that new line that we just had. And so what we've done is we've been able to take this Magpie 4 version of random response, which went from line 209 to line 233. So, 24 lines of code here. And we've been able to break it down basically to 2 lines of code plus 1 variable that keeps track of everything in an array literal. And if I want to add random responses, like if I want to add another random response, I just add one more thing to this array literal. So I can say, that's fascinating. And now if I compile this and run it again, just by making that one change, eventually I'll hit that random statement. I've got 6 different random statements that I could hit. Interesting, tell me more. I'm bored, tell me something different. Do you really think so? You don't say. You don't say. That's fascinating. So I can hit all of those random responses, and the only thing that we're really doing here is just changing one part of this. We're not even changing the method. We're just changing the array literal. And so this brings up an interesting idea. We can go up to the methods that we had before. We had 2 methods that we had. We had this I want to statement that we could transform, and we had this I want statement that we could transform. And I'm going to try and get both of these on the screen at the same time. What I want you to do is I want you to notice the similarities between these 2 methods. These 2 methods essentially do the same thing. And if I want to add a method that I like, or if I want to add a method that I hate, it would run about the same way. So first thing we do is we trim. That's the first thing we do is get rid of any punctuation or any spaces. We get rid of the terminal punctuation by using the last char. to get the last element of the string, and if it's a period, then we basically get a substring from it. And then we declare a PSN variable to find the position of this particular statement. And then what we do is we find the rest of the statement. We take a substring, and of course this 6 and this 9 are different, but the reason this is 9 is because this is the the 1, 2, 3, 4, 5, 6, 7, 8, 9 characters, and I want 2. The reason this is 6 is because of the 1, 2, 3, 4, 5, 6 characters of I want. So I really could change this to the string here, the string length. And then I can make this, would you really be happy if you had blank? Or what would it mean to blank? So in other words, the logic behind this is the same no matter what I'm doing. So if I were to create some string literals, so let's go ahead and do this. So private string array leading statements. And I'm going to set it equal to I want 2, and I want semicolon. So now I've got this array here, which is my leading statements, and I can do string array leading statements response. And of course, the response to I want to is what would it mean to, plus the rest of the statement. The response to I want would be, would you really be happy if you had? And then terminate that with a semicolon. Then all I would need to do is this part would stay the same. This part would stay the same. This part would stay the same. Because all of this is just taking off the last period. But instead of looking for I want, this would actually just look at leading statements sub 1, because that really is the first element of that list. And then this 6 comes from the length of leading statement sub 1. Dot length. And of course, because these are strings, length is a method. And then instead of forcing it to say, would you really be happy if you had blah, what I would do is I would say, return leading statements response sub 1 plus the rest of the statement. So in other words, this method does exactly the same thing, but instead I'm preparing it, I'm refactoring it to use these arrays. So if I want to add another element, like if I want to add I like to this, then what I would do is down here change the response to what do you like about? And so all I really need to do now is say, well, I could copy this method again and just have it be a 2. And then it would go through the I like and what do you like about. And if I want to add another thing, like, well, I don't know. I hate, then I can go down here and say, what's so bad about stuff? So if I say I hate Limburger cheese, the computer would respond with what's so bad about Limburger cheese? And so what I can do here is I can actually transform this. Let's call this, instead of transform my want statement, to transform leading statement. In other words, this is going to transform any particular statement using the leading statement. And instead of forcing it to use statement 1 or forcing it to use statement 2, this could be another parameter that I set. I could pass a parameter like int I. And so this is going to tell me which of these leading statements. Statement I is the one that I'm going to deal with. Statement I is the one I'm going to find the length of. And statement response I is the one I'm going to respond with. And so what happens is, if I want to get to the I want, then I'm going to call on this with a 1. In other words, I'm going to transform leading statement with the parameter statement 1. If I want to do this I want to, then I'm going to do this to transform leading statement with the statement comma 0. And I can continue this idea with if the keyword I'm looking for is I like, then, well, that's statement 2. And I can do I hate. That would be statement 3. And so what happens is I don't even need this transform I want anymore. What's happened is I've got this transform leading statement. So what I've got here is leading statement and transform it to leading statement response something. The only thing here is that I now have a new parameter. The first parameter statement was the user statement assumed to contain leading statement. And so now I have a new parameter called I, the index of the proper leading statement and leading statement response. And so the idea here is that I now have this one method that takes care of I want to, and I want, and I like, and I hate, and responds accordingly with what would it mean to, or what would you be happy if you had, or what do you like about, or what's so bad about, to the corresponding response. In other words, these are matched because of this index I. Because I'm going to look at leading statements index I. I'm going to look at leading statements length at I. And I'm going to look at the leading statements response at I. And if I want to add more statements, all I'm going to do is I'm going to pop them in here. But I also have to pop them here. And so there's another thing that we could do here. We could take all of this and set it up as a loop. So what I can do is for int loop control variable gets 0, LCV is less than leading statement dot length LCV plus plus, and go through this loop and say if find keyword with statement and leading statement sub LCV, if that's true, then I want to do the following. I want to say response is equal to transform leading statement with statement and my loop control variable. And if that's my response, then I really want to break. I don't want to go through this loop again, because I've got I want to and I've got I want, and both of these would end up triggering. So I want to make sure this find keyword here is greater than or equal to 0. And if that's true, we're going to find a response and break. If it's not true, we're going to continue to the next element in the loop control variable. And now that means that I don't even have to change anything in here anymore, because this depends solely on the length which I have control over. The transformations down here, this transform leading statement, is controlled by the loop control variable. It's controlled by I, which really is controlled by the length of these arrays. So I could add other elements to this. I can say, I don't know, I adore. And I can put down here in a response, after I put a comma, what's so adorable about my rest of my statement. So let me go ahead and compile this. I'm sure I've got a few errors in here, and I'd like to take care of those real quick. So cannot find symbol. It doesn't know what leading statement, because it's leading statements. So just simple spelling issues. Leading statements, leading statements. And is this the method is called transform leading statement. Does this compile? Nope. Still one more error to find in here, and that is doesn't know what leading statements dot length. Leading statements. Yeah, I can't spell. So what is the error now? Leading statements dot length. I do have leading statements, don't I? Leading statements. Let's copy that and paste that here, and paste that here. Does that work now? No. I'm an idiot. It's an array. It's not a string. It's an array of strings. So it should just be dot length. It shouldn't be dot length as a method. It should be dot length as an instance variable. All right, so let's go ahead and try and run this with some of the things we've got. So, hello, let's talk. So I can say I like radishes. What do you like about radishes? I like to dance the mamba. What do you like about to dance the mamba? And of course, tense is an issue here, but it's copying. It's doing the method we're supposed to. I see. What do you like about stuff? Let's do another one. Let's say I hate corn on the cob. What's so bad about corn on the cob? I adore one dimension. What's so adorable at one dimension? So it's going through the array that we've established. And it's responding in part with the statements that we've got here. The I want to, the I want, the I like. So it's doing everything. Let's try the I want. I want world peace. You don't say, I want world peace. Would you really be happy if you had world peace? I want to save the world. What would it mean to save the world? So this refactoring has taken this really two methods that do the same task, and we've really made it so that we can make it any number of methods that do the same task. So I've refactored this idea of a leading statement, where if I ask a statement with a leading keyword, then it'll add a leading response to it. What I'd like you to do is to do the same thing for these that have a leading and a following. There's two things that we're looking for. Something that comes first, something that comes afterwards, and then of course we're going to get a response from this. So if I want to refactor these methods, I'm going to need to have three arrays. Instead of just having the leading statements array, I'm going to have a lead, I'm going to have a follow, because I've got you and me, or I and you. And then I'm going to need my responses as well. So I'm going to need three arrays, three array literals that I'll have to change. And then we're going to need to take a look at this, transform you, me, or transform the I, you. Look at what's similar. Look at what's different. And try and refactor it so that you can include one method that'll transform a whole litany of A statement, B sentences. That's what I'd like you to do. And that's going to finish up Magpie for us. So once again, this is Mr. Potter. Thank you for watching. Have a great day.